talk about section 1.8, linear and absolute value inequalities. The first concept that we need to discuss in this section is the topic of interval notation. Interval notation takes some getting used to if you've never seen it before. So we're going to do a few examples, just kind of getting used to what interval notation means and making sure we're comfortable with how it looks. Let's start with, I've got a couple of number lines drawn up here. I want to express an inequality like x is less than 4 in interval notation. So let's write, I want to write x, let's do x is less than 1. I want to write x less than 1 using interval notation. In order to do this, I need to graph it. Let's see what it looks like on the graph. If I graph x less than 1, I'm going to locate the 1. All right, you probably think about, I know you've done these before, so you have to remember, sometimes you used an open circle, sometimes you used a closed circle. If this is just strictly less than and it does not have equals with it, you're going to use the open circle. So we're going to find the 1, we're going to draw an open circle, and we want everything less than 1, so everything smaller. We want to graph everything to the left, back this way. So we're graphing x less than 1. Okay. In this class, I will tend to use a different symbol in place of the open circle. I will be using these round parentheses to mean the exact same thing. So that's the same graph of x less than 1, but I'm just using the round parentheses symbol in place of the open circle. Once I have this graphed, I'm ready to give the interval notation. The interval notation is like it's almost like, you can think of it as a shorthand way to write what you just graphed. So we're going to read our graph from the left side to the right side, and we need to say where the graph begins and where the graph ends. So for interval notation, we're going to say that the graph is beginning over here at negative infinity. It's going forever in this direction into the negative values. So it starts at parentheses negative infinity, and then it continues going left to right until it gets to 1, and then it stops at 1. 1 is not included, so we can indicate that 1 is not included with the round parentheses symbol. So that would be my interval notation. Parentheses negative infinity, comma 1, parentheses describes the graph that I've just done here. Okay? Let's do another one. This time we want to, let's say I want to graph x greater than or equal to negative 2, and then I want to give my answer in interval notation as well. Okay? So let's locate, how do you graph x greater than or equal to negative 2? Here's negative 2 on the graph. All right, you probably would use a closed circle at negative 2. Well, I shouldn't say probably. You would use a closed circle at negative 2. Why do I use the closed circle? Well, because this time this says that x is greater than or equal to. So the closed circle tells me to include the negative 2 as part of my solution set. So starting from negative 2, now I graph everything larger than negative 2. So I'm going to shape everything to the right of negative 2 on my graph. Okay. In this course, we will be using another symbol that means the same thing as the closed circle. We're going to use a square bracket. So we can draw a square bracket like this, and then shade everything to the right. Okay. So the square bracket replaces the closed circle. The round parentheses symbols replace the open circles. And try not to get confused using those new symbols. You'll notice that try not to worry about which way to have your symbols, what direction to have your symbols in, because if you notice, the symbol is always going to enclose or just kind of surround the area that's been graphed. So if you graphed everything on the left side, then you're going to use the symbol that kind of points to the left side. And over here, we've graphed everything this way, so we would use the square bracket that kind of points to the right side, like about that. So that's how we decide which way to point the brackets and the parentheses. You don't have to use the brackets and the parentheses, you can still use the circles, but the brackets and parentheses are used in interval notation, so it's good practice to go ahead and use it on the number line as well. All right, so now that we've got a graph to look at, how would we write this same value using interval notation? We need to express this graph in interval notation. So again, we read our graph from left to right. If you start over here on the left side, where does the graph begin? It begins when x is -2. And we include the -2 indicated with a square bracket. So we're going to say square bracket, -2, comma. How far does the graph continue? Well, it continues all the way out to positive infinity. And this is the infinity symbol, like a sideways 8. And then infinity always has the round parentheses with it. So my interval notation is square bracket, -2, comma, positive infinity. And I hope you can see. Can you see that? Yep, you can see that. Okay, good. All right, so let's just kind of recap. There's a lot of new symbols and a lot of new terminology here. First of all, the infinity symbol looks like a sideways 8. It just simply means that you're going out positive direction forever. This is the negative infinity symbol. It just has a negative sign in front of it, and it tells you that you're just way out here to the left forever. You use a closed circle or a square bracket, closed circle or square bracket, or this, just depending on which way your graph is going, to indicate. You use this if you've got x is equal to, so like if you've got x less than or equal to, x greater than or equal to, you're going to use the closed circle or the square brackets. If you have x less than or x greater than with no equal signs, then you can use the open circle, and you would use one of those parentheses depending on which way your graph is going. Just checking to see if you can see that. Okay. All right, let's look at some more examples. This does take some practice. Let's look at the example in the notes. Example 1. Example 1 asks us to write an inequality whose solution set is the given interval. Okay, so for part A, we have interval parentheses, -infinity, comma, -9, parentheses. Okay, so let's start by graphing this. Okay, now I'm not going to put every number from -9 to +9 up here. That's not necessary. Here's -9. I'll put some numbers surrounding it. Okay, how do we read this interval? This is -infinity to -9. And I'll ask you, does this include the -9? No, it does not, because it's got the round parentheses. That's like having the open circle. So we want to shade everything from -infinity to -9 on the number line. When we come to -9, you can use either the open circle or you can use the round parentheses. I'm going to do it both ways because I think it's helpful to see it both ways. All right. Now that I've got it graphed, I can give the inequality. I'm being asked to, they said write an inequality, so that means you're going to write it in terms of x. So if you think of this in terms of x, how could you describe this? We've shaded everything less than -9, so we need to say that x is less than -9. Because x corresponds with the areas that have been shaded. X is the answer, and the shaded area is our answer. So x is less than -9. So this is the inequality. That means the same as interval notation, -infinity to -9. Let's look at part B. We have square bracket 0, comma, infinity. Okay, so I'm just going to put, I'm not going to put a large number line, it's not necessary. All right, I just need this number and a few numbers around it, and that's enough. I need to shade everything from 0 to positive infinity. Again, integral notation is always read from the left to the right, just like the number line is read from the left to the right. So go to the 0. If you're thinking in terms of circles, decide what type of circle you would need. This is a square bracket, so that means that 0 is included. So you can do this closed circle at 0, shade everything larger because it goes all the way to positive infinity. So go this way, and then you can do, or you could say square bracket, graph everything to positive infinity that way. And then we want to write it as an inequality involving x. So if we think of this in terms of x, we have started at 0 and we went out forever, so we want everything that is greater than or equal to 0. So our inequality would be x greater than or equal to 0. So that's the inequality for the integral notation that we see up here. For example 2, we are asked to solve the linear inequality and then write the answer in integral notation. How is this different from what we were doing already? Well, we're just building on it a little bit. Solving a linear inequality is very much like solving just a regular linear equation. You do have to be a little bit careful. For example, let's talk about how you would handle this if instead of the less than symbol, what if you had an equal sign? If you had an equal sign, you know that you would do negative 3x minus 9 equals 0. You would add 9 to both sides. You would solve negative 3x equals 9. You would divide both sides by negative 3. And you would have x equals negative 3 for your answer. Okay? Well, we do this very much the same way, but with it being an inequality, we have a lot more answers than just negative 3. We're going to have everything either larger or smaller than negative 3 for our answer, so we have an infinite number of solutions here. Another thing that you have to be super careful about, this is in your notes, but make sure that you remember this. If you recall from working with linear inequalities in the past, anytime that you multiply or divide both sides of an inequality by a negative number, you have to be careful that you remember to flip the inequality symbol. I'll take a moment and explain why that happens. For example, let's say you've got 2 is less than 5. Okay? We know that's a true statement. What if I multiply both sides of this by negative 1? If I multiply both sides of this by negative 1, that becomes negative 2. Negative 5. Negative 2 less than negative 5 is a false statement. So as you can see, multiplying or dividing both sides of an inequality changes the original truth value, or excuse me, it changes the truth value of your original statement. So in order to maintain the truth of your equation, or your inequality rather, make sure that you remember to flip the inequality symbol anytime that you multiply or divide by a negative number. So make sure you remember to do that. Do whatever it takes to make sure you don't forget. And now let's take a look at how to handle part A. So I'm going to start by adding 9 to both sides. And then I'm going to divide both sides by negative 3. Let's see, I want to write an extra symbol. So negative 3x divided by negative 3. And because we are dividing by a negative, we need to flip the symbol to a greater than symbol. So divide both sides by negative 3 and flip your inequality. That gives you x is greater than negative 3. So this is the inequality version of the answer involving x. We're asked to give the answer also in integral notation. Look at the graph first. So I've got negative 3, it's going to go right in the center, and then I need some numbers on each side of negative 3. Okay. I need to graph x greater than negative 3, so you can do the open circle, but I'm going to go ahead and use the round parentheses now. Shade everything to the right side. Okay. Now that I've got it on the graph, the integral notation is like just a shorthand way of writing the graph. The integral notation begins, well, the graph begins at negative 3, so my integral notation, I need to write parentheses, negative 3, comma, And then how far does it go? It goes to positive infinity. So put the infinity, and infinity always has the round parentheses symbol with it. It never has a square bracket with infinity. So that's your interval notation. Parentheses, -3, comma, infinity, parentheses. Example 2, part B, we have the same directions. We have to solve and write in interval notation. You're probably noticing that you've got fractions this time, and most people don't like having to deal with fractions, and that's okay. Just like you could do when you were working with equations, if you recall, if you're working with equations that involve fractions, you have the privilege, I guess you could say, of eliminating those fractions if you just multiply both sides of the equation by the LCD. You can do the same thing here as well. What is your LCD? Take a moment, think about that. Pause if you need to. Okay, so you look at all of your denominators. You've got a 2, that's a 1, that denominator is a 4, and that denominator is a 1. So looking at all of these denominators, you want the least common multiple of 2, 1, and 4. The least common multiple is going to be 4. That's the smallest number that each of these denominators can evenly divide into with no remainder. Okay, so my LCD is 4. So I want to multiply each term. I want to multiply both sides of my inequality by my LCD, and of course I have to distribute. So you can think of this as multiplying each term by your LCD. So we're going to do 4 times 1/2 x minus 3 times 4 greater than or equal to 4 times 1/4 x plus 4 times 2, or 2 times 4, either way. And simplifying this will eliminate the fractions. 4 times 1/2 x is going to be 2x minus 12 is greater than or equal. 4 times 1/4 x is just going to be 1x plus 8. All right, I'm going to ask you to pause here and continue with the problem and see how far you can get with it, and we'll check when you come back. Okay, so let's see how you did. First, you do not have to do the same you do not have to do your steps in the same order that I'm doing mine in. We'll talk about different ways that your answer might look at the end. But because this is an inequality, I personally find it helpful for my x to essentially land on the left side of the problem. If you've got x is less than a number for your answer, or you've got x is greater than a number for your answer, that's a lot easier to visualize on the graph than if you get something like 6 is greater than x. So whenever you're working with inequalities, it's going to be helpful if you try to get your x to end up on the left side of the inequality in the final answer. So in order to accomplish that, I'm going to subtract x on both sides. And that gives me x minus 12 is greater than or equal to 8. And now I want to add 12 to both sides. So x is greater than or equal to 20. Okay, so x is greater than or equal to 20. Before I give my answer in interval notation, I would like to see how it looks on a graph. Again, I'm not going to put a lot of numbers on here. I'm going to put the number that I need and just a few on each side. Okay, I need to graph everything greater than or equal to 20 on my number line. So I'm going to locate 20. I notice that 20 is included, so you could use a closed circle, and I don't know if you can see that. Let me see if you can see that. You could use a closed circle to indicate that 20 is part of the solution. I'm going to use the square bracket. And I'm going to shade everything larger than 20, everything greater than. So I'm going to have a square bracket at 20 and shade everything to the right. And it's very important that if you're doing a problem, if you're doing a graph on a test in the classroom on paper for me to check, make sure that I can see where your graph is. Sometimes it's not clear where the students draw their graphs. Sometimes the whole thing might be like the same shade and I can't really tell where it's graphed. So just make sure I can see where your graph is supposed to be. So this is the graph, and now to give the answer in interval notation, I'm just going to say that, well, my graph starts at 20, and I've got the square bracket at 20, so my interval notation needs to start with the square bracket 20. So square bracket 20, comma. How far does my graph go? It goes out to positive infinity, and I know that I always put round parentheses with infinity symbols. So this is my interval notation. Square bracket 20, comma, positive infinity. The next topic that we need to discuss is intersection and union of sets. And to help us understand that, I've just drawn, or I've given you as a very specific example to take a look at. Let's say I've got these two sets. I've got set A, and set A has elements 1, 3, 5, 7. Set B has elements 3, 7, 9, 11. Okay, the easiest way to probably explain what intersection and union means is just by showing you an example. I have the definition in the notes, but you probably didn't really understand what it said. So intersection means that you're looking for things that you're looking for where the two sets overlap or where they come together. What do you see that occurs in both sets? If you take a moment and look at it, you might say that they're intersection. What goes into the intersection? Well, I can put set 3 appears, 3 appears in set A and in set B, so I can include 3. And the element 7 appears in both sets. So 3 and 7 would be the intersection of set A and B. There is notation that goes along with this as well. Intersection is denoted with like an upside down horseshoe. All right, so we can say A intersect B equals set with elements 3, 7. Okay. Union is a little bit different. Union means you basically take everything. It all goes together. The symbol for union looks like a U. So this is the symbol for union. This is the union symbol. So we can say that A union B. And again, union just combines it all. Union takes everything. So I'm going to list everything that I see up here, like the total, all of it. Now, if something is repeated, I don't have to write it twice. So for my union, I need to say 1, 3, 5, 7. All right, that's everything from set A. And then in set B, I've already got 3, I've already got 7. But I also need to include 9 and 11. Okay, so union takes it all, everything. Sometimes students have a little bit of difficulty understanding how to differentiate between intersection and union. I'm going to give you kind of a strange little example, but it might help you understand it. If you think about union, what's another type of union that you might think of? An example would be a marriage. In a marriage, everything that the husband has, everything that the wife has, is all combined and brought into the union of the couple. Intersection, if you're just intersecting one another, if a couple is just intersecting one another, they're only sharing a little bit. They're not sharing very much. So, and also the symbols, that looks like an N and that looks like a U. So hopefully that'll help you to keep it straight a little bit. All right, so let's go on to the next example in the notes. So for example 3, we are asked to find each of the following sets, and we're asked to write our answers in interval notation. I have drawn number lines to help us through this. So these are the original sets A, B, C, and they are given to us in interval notation. So I'm going to graph set A on this first graph. So this is set A. I'm going to graph set B here, and I'm going to graph set C here. So set A is the interval from 1 to 5, and it does not include the endpoints. So I need to shade from 1 to 5 on set A. my graph for set A. Set B is integral from 3 to 7. I need to include the 3, but not the 7. Square bracket at 3, shade all the way up to 7, and put the round parentheses on 7. Set C is everything from 6 to infinity, and 6 is not included. So parentheses at 6, shade everything to the right, positive infinity. All right. So we can use our graphs to help us find the sets that we're asked to locate. In part A, we're asked to find set A union B. So again, here's set A, here is set B. Union is telling me to take it all. So everything from set A, everything from set B is going to go into my answer. So can you see where that would be? Pause the video for a moment and think about it, and then we'll talk about it together. Okay, so if you combine, or if you take everything from set A and everything from set B and put it all into a union, you're going to have everything beginning at 1, going all the way out to 7. So you would say that that's the integral from 1 to 7. And that includes everything from here to here. So A union B is integral notation, parentheses 1, 7. Part B, A intersect B. All right, again, pause it, think about it for a second. So A intersect B means that you only take the areas where sets A and B overlap, where they touch. And they only touch from here to here, so from 3 to 5. All right? For our interval notation, our symbols will match the symbols that we are seeing here. So starting from 3 with a square bracket, the two sets intersect all the way up until we get to 5 with the round parentheses. So our interval is square bracket 3, 5 parentheses. All right, I'll let you go ahead and pause and continue with part C and D, and then we'll talk about those. So for part C, you're asked to find A union C. So you need set A here and set C here, all combined into one set. All right, now you'll notice there's a gap. From 5 to 6, there's a gap. All right, so you probably didn't know how to write that. We're going to say everything from 1 to 5, in parentheses, union, use the union symbol, and then you can include the interval from 6 to infinity. Okay, so we've got interval 1 to 5 union, interval 6 to infinity. One thing you have to be really careful about is that sometimes interval notation can look a lot like an ordered pair. For example, if you just looked at this, you would probably read that as x equals 1 and y equals 7, which is a totally different topic. So just be really careful that you don't confuse that. This is the interval from 1 to 7. In part C, we've got the interval from 1 to 5, union interval from 6 to infinity. And then for part D, when we do A intersects C, intersection means that we're looking for where they overlap. All right, well, set A only goes up to 5, and then set C begins at 6, so they never overlap. They never touch at all. So A intersects C is going to be the empty set. For empty set, you could write set notation with nothing inside, or you could do a circle with a slash through it like that, either way. Okay, so you should have read in your notes just before you get to example 4 that a compound inequality simply means that you're going to be working with more than one inequality at the time, and they're going to be connected with a word and or. The word and will imply that you need to use intersection. The word or means that you need to use the union of the two sets. So looking at example 4, part A, we need to solve the inequality, the compound inequality 2x minus 3 greater than 5 and 4 minus x less than or equal to 3. So we are going to solve each one individually first. So with the first piece, let's add 3 to both sides. 2x is greater than 8. Divide by 2. So we get x is greater than 4. And then the second inequality, again, we still want to keep x on the left side. So let's subtract 4 on both sides first. And we get negative x less than or equal to -1. So we need to divide both sides of this by -1. So that's going to give you, or you can think of this as multiplying both sides by -1. Either way, you should have positive x is greater than or equal to +1. So make sure you remember to flip your inequality since you're multiplying or dividing by a negative. So these are our two pieces. We've got x is greater than 4 and x is greater than or equal to 1. How are we going to give our final answer in interval notation? We need to look at the graph first. So x greater than 4, again, notice I'm only putting numbers on here that only the numbers that you really need and just a few around those numbers. X greater than 4. Because this has got two individual pieces to it, I am going to hold off and put on the final answer on the graph until I can see what each piece looks like. So if I look at x greater than 4, I would shade everything to the right of 4. So I'm not going to put it directly on the number line yet. I'm just going to come above the number line and shade everything greater than 4. You can do an open circle or you can do a round parentheses symbol. So that's x greater than 4 there. And now I need to do x greater than or equal to 1. So find 1. I want to shade everything greater than. And I'm going to use either a closed circle or a square bracket. And this time I'm going to come below the graph. So that's x greater than or equal to 1. The reason I did not put them on the graph yet is because I still need to take into account what operation I need to use. And it's telling me to do the intersection. So if I take the intersection of these two individual pieces, where does my final answer need to fall? Think about that for a moment. Pause the video. Okay, because and means intersection, you only take where the two graphs touch or where they're coming together. So only from 4 out to positive infinity is where the two graphs meet. And you're going to use the same symbol that you have here. You'll use the round parenthesis symbol and shade everything greater than 4. So this is my final answer on the number line itself. I'm going to erase these little pieces that help me arrive at my answer. I have to give my answer in interval notation. So it would be, interval notation will be parentheses 4, comma, infinity, parentheses. Example 4, part B, we need to solve and express our answer in interval notation. 4 minus 3x less than -2, or 3 times x minus 2 in close parentheses less than or equal to -6. So we'll go ahead and solve each for x. Subtract 4 on both sides, you'll have -3x is less than -6. Divide by -3, and because you're dividing by negative, you have to make sure you flip your inequality symbol. So you'll have x greater than +2. Over here you've got 3x minus 6 less than or equal to -6. Let's add 6 to both sides. So you've got 3x is less than or equal to 0, and divide both sides by 3. X is less than or equal to 0. Okay, and now I need to see what this looks like on our number line. So now we'll graph the two individual pieces, x greater than 2. I'm going to put it above my graph. So I'm going to do the round parentheses and shade everything greater than 2, like this. You could also do the open circle. X greater than or equal to 0, I need to shade everything smaller than 0, including 0 itself. So I'm doing a square bracket and shading everything to the left. Now, again, make sure that you pay attention to what operation you need to use. The word or is telling me to take the union of the two sets. Union, again, means you take all of it into the union. So we're going to include this piece and we're going to include this piece, and they both go into our final answer. So we can graph everything from -infinity up to 0. Shade it very clearly on the graph. and everything from 2 with the parentheses to positive infinity. You can erase the little pieces that you use to arrive at your final graph.
Hi guys,
And
this
then
is
we need
Miss
to give our
Lewis.
answer
I'm
in interval
goofed
notation.
up in that video. That should say parentheses negative infinity to 0 square bracket union parentheses 2 to positive infinity. So on the left side, the graph begins with negative infinity, not with negative 3. So parentheses negative infinity to 0 square bracket union parentheses 2 to positive infinity. Okay, back to the video.
Example 4, part C, we're asked to solve this. This is called a 3-part inequality, or sometimes we call it a sandwich inequality. Negative 4 less than or equal to 3x minus 1 less than 5. So this is really the same thing as an and statement, but the and statement can be written all in one inequality with 3 parts. To solve this, we're going to, let me find something. We're going to basically do the same steps that we would do with any inequality. It's just that we have 3 pieces to handle. So instead of having 2 sides of your inequality, you have 3. If we just cover part of this up and look at this as 3x minus 1 less than 5, whatever first step that you would typically start with here, we're going to do the same thing. You would probably start by adding 1 to both sides. We just add it to all 3 sides. So we're going to do plus 1, and do a plus 1 back here. So negative 4 plus 1 gives me negative 3. All right, these ones cancel out in the middle, and then I'm dividing 1 gives me 6. All right, again, cover this piece up, and you can see that you would want to divide everything by 3 to get the x by itself. Your goal is to get x by itself in the middle. So divide all 3 sides by 3. Okay? Now, we get negative 3 over 3 gives me negative 1. I did not flip the inequality symbol because I divided by a positive 3. So you're getting negative 1 is less than or equal to x less than 6 divided by 3 is 2. So this is the inequality. How do we express this in interval notation? Let's talk about what the graph of this is going to look like. So my inequality is indicating that x is between the values negative 1 and positive 2. The graph will reflect the same thing. I need to shade everything between negative 1 and positive 2. All right. The symbol here tells me what to put at the negative 1. All right. So if you were to read this, if you were to break this apart, it would say x is greater than or equal to negative 1. So you need to use the closed circle or the square bracket at the negative 1. Over here, this is x is less than 2, so you can use the open circle or the round parentheses at 2. So this is the graph from negative 1 to 2. Interval notation can be read directly from the graph. So our interval notation is going to be square bracket. Well, I'll let you think about it for a second. So your interval notation will be square bracket, negative 1, comma, 2, parentheses. And that is our answer, interval notation. So the absolute value inequalities. What does it mean for the absolute value of something to be greater than or less than a number? First, let's talk about what does absolute value mean. Well, in your notes, you should see that the absolute value is the absolute value of a number is defined to be a measure of its distance from 0 on the number line. So that's why if you find the absolute value of 3, and the absolute value of negative 3, they're both equal to 3 because they're both a measure of distance. So absolutely, you know that you probably remember absolute value is always positive or 0, and that's why. So if I've got something like this, like you have in your notes, absolute value of x less than 3, what does that mean? Well, numbers that would satisfy this inequality would include any number that is fewer than 3 spaces away from 0. So just think about that for a moment. Think of some numbers that are fewer than 3 spaces away from 0. For example, 7. Is 7 more spaces from 3? Excuse me. Is 7 fewer than 3 spaces from 0 on the number line? No. So 7 is not a possible answer. Is 1 fewer than 3 spaces away from 0 on the number line? Yes, so 1 will satisfy this inequality. What other numbers are going to satisfy this inequality? You can go ahead and think of, you can kind of color in the 1 if you want to on the number line. What about 2? 2 is fewer than 3 spaces from 0, so 2 can be included. Right? 0 can be included, negative 1, negative 2. Now sometimes people tell me that's all, but it's not, because you want to make sure you're including, for example, 1/2, 1/4, 1/3, negative 1/2, negative 2.5. So basically you're looking at an interval of all values between negative 3 and positive 3. Because this is a strict inequality, it does not include equals, we would use round parentheses to show that all of the solutions of this are going to fall between negative 3 and positive 3. How do I write this in an interval notation? All right, make sure you're filling this in your notes, because that's something that I'll be checking for. How do you fill this space in? Interval notation, you're going to write this as parentheses, negative 3, comma, positive 3, close parentheses. All right, and then in the notes it said I was asking for an equivalent statement. What I'm meaning there is, how can you write that as an inequality involving x? In other words, how can you write what we've graphed here using x? Well, you need to show that x is everything between negative 3 and positive 3. So one way you could write that would be with the sandwich inequality. So you can simply say that negative 3 is less than x less than 3. So that means the same thing. Everything between negative 3 and positive 3. Okay, our next example, we have absolute value of x greater than or equal to 2. Again, we want to think about what does it mean for the absolute value of x to be greater than a specific number. That means that its distance from 0 is more than 2. Or you're looking for numbers that are more than 2 units away from 0. Think of some examples. Pause if you need to. See if you can decide how to graph it. So you've probably determined that numbers that are more than 2 units away from 0 would include 4, 5, negative 3, negative 4, 2.5, 3.5. So you would want to draw the intervals of everything beyond 2 this way. So greater than or equal to 2. We needed the square bracket because it's got the equals with it now. And also everything less than negative 2. Anything out here is going to be more than 2 units away from 0. How do we write this in interval notation? We're going to say this goes from negative infinity to negative 2. We put the square bracket with the negative 2, again because of the equals in the original problem. We've got a gap in our graph, so we're going to use the union symbol here, and then square bracket 2 to positive infinity, parentheses. How do we write this as an inequality involving x? Well, negative infinity to negative 2 comes from here, and you can see that's everything less than or equal to negative 2. So x is less than or equal to negative 2. All right. Remember, the union symbol means this is it means the same thing as or. So we'll say or, and then for this piece, x is greater than or equal to 2. So the discussion that we've just gone through showing how the absolute value of x being greater than or less than a number creates a certain graph, and then the interval notation and the inequality version of those graphs gives us the rules that we need in order to solve absolute value inequalities. You'll find the rules explicitly stated at the bottom of your note, the same page of notes. We've got, it's in terms of k. Sometimes that's confusing for people. K is just a constant. But you'll see the rule at the bottom of the page that we were just working from. Those rules are essential to being able to solve absolute value inequalities. And hopefully you'll understand why we have those rules based on what we just talked about. So let's go ahead and look at example 5. So example 5, part A, we're going to solve absolute value of 3x plus 2 is less than 7. Because this is the absolute value less than a number, we'll go to the sandwich inequality. The rule says that we're going to take the opposite of the constant that we have here. So we're going to take a negative 7, set that less than the inside of the absolute value. So we'll set that less than 3x plus 2. And then that's going to be less than the constant, 7. And then we can solve that. So just like with any sandwich inequality, you're going to want to get your x by itself in the middle. So you can see that you want to start by subtracting 2 on all 3 sides. I get negative 9, less than 3x, less than 5. All right, and again, if you look at it, you can see you're going to divide everything by 3. So divide all 3 sides by 3. We've got negative 3 is less than x, less than 5/3. The directions ask us to graph the solution set. It does not specifically say to use interval notation, but we're going to do that anyway just to make sure we're comfortable with it. So let's go ahead and graph this. Where is 5/3 on your graph? 3 goes into 5 not quite 2 times, so it's not quite 2. So it's going to be just a little bit before you get to 2. You're going to shade everything from, so x is telling you where your solutions are. They're everything between negative 3 and 5/3. And they do not have equal signs with them. They're just strict inequalities. So what symbols will we be using at our endpoints? We'll be using open circles or the round parentheses. So we're going to go negative 3, parentheses, shade everything about almost up to the 3, not quite there, and shade all that in. Okay, that's our graph. For our interval notation, we would have parentheses, negative 3, comma, 5/3, and then close your parentheses. This is the interval notation. Example 5, part B, we want to solve negative 2 times the absolute value of 4 minus x less than or equal to negative 4. All right, before we can do anything, we need to isolate that absolute value first. In order to isolate our absolute value, we need to break this apart. So we want to divide both sides by this negative 2. All right, make sure that you remember, when you divide by a negative, you flip your inequality symbol. So we have the absolute value of 4 minus x greater than or equal to positive 2. And now we can set up our 2 cases. Because this is a greater than, this is going to be an or statement. If you think you're going to have trouble remembering that, you can think of the silly little word greater. Okay, greater. So if it's a greater than absolute value inequality, you'll use the or statement to separate the 2 inequalities. We're going to do 4 minus x greater than or equal to 2, or, and again, go back to the rule at the bottom of the last page where we were discussing the inequality, absolute value inequalities. That's where the rule is. It says that you're going to do the inside of the absolute value greater than or equal to the number that you have here, or the inside needs to be less than or equal to the opposite of your constant. So 4 minus x less than or equal to negative 2. Solving for x on the left, we're going to subtract 4 on both sides. We have negative x is greater than or equal to negative 2. Divide both sides by negative 1, and you've got positive x is less than or equal to positive 2. For my second inequality, I want to, again, keep x on the left side, so let's subtract 4 on both sides. That gives us negative x less than or equal to negative 6. Now divide both sides by negative 1, and you've got x is greater than or equal to positive 6. All right, so let's see what this looks like. On the number line, I'm going to pause it just to save my battery real quick. So we're going to graph x is less than or equal to 2, or x is greater than or equal to 6. So less than or equal to 2 is going to put me back here with a square bracket or with a closed circle. X greater than or equal to 6 puts me over here with a square bracket shading to the right. My integral notation will be, think about what you think the integral notation should be. Pause if necessary, but integral notation is going to be negative infinity to 2 with a square bracket. Union, because you've got a gap, so we put the union symbol, and then you can do square bracket, and I apologize, I'm running out of space. Square bracket 6, comma, infinity, parentheses. So parentheses negative infinity to 2, union, square bracket 6, comma, infinity with parentheses. There's a better view. Example 5, part C, we're asked to solve absolute value 7x minus 9 greater than or equal to negative 3. Okay, now before I start trying to set this up, let's take a moment and think about what this is saying. What do we know about absolute value? If you take the absolute value of any number, you know it's a measure of distance. So will it ever be negative? All right, I'm going to stop. I'm going to ask you to pause the video, give this some thought, think about what you know about positives and negatives, greater thans and less thans, and just give it a moment. So, because absolute value is always positive or 0, we've got a positive here greater than or equal to a negative here. Okay? That's either always true or always false. Which one is it? A positive is always greater than a negative number, so the answer to this is going to be all real numbers. Or you could say infinite solutions. If you don't notice that, you can go through the steps, but then when you go to graph it, if you're graphing it correctly, you should end up with the entire number line shaded. So you'll have other problems similar to that that might be a little bit tricky. And if you're running into some major issues when you're trying to solve these absolute value inequalities, you might need to kind of take a step back and think about what they really mean. And that might shed some light on why you're having difficulty possibly with it. Okay, I believe that's it for that section. So yeah, this finishes chapter 1. Chapter 1 is now complete. So make sure that you bring good questions to class, and we will discuss this further in class.